All right, so this next section is 6.2 global energy consumption. So we're going to be in this section looking at trends throughout the globe in terms of the resources that we use globally or on a global scale as opposed to just here in the US. Okay, so the first thing that we have to kind of tackle here with this is how the difference between like developed countries, what types of energy resources we use in developed countries versus developing countries. And so developed nations use, as you would expect, way more energy on a per capita basis than developing nations. So the average US resident uses 5 times as much energy as the world average. We've talked about this before. We're not the worst country, but we're almost the worst country. Canada actually uses just as many resources as we do. So here in North America, when we designed our cities, we didn't really think about small. We had so much land, we thought we just spread things out. And so just for me to get to work, I don't live right next to the high school. Some of you might, I don't. So I have to drive, and that's true of many people. Even just to get across Fishers, we can't use public transportation. We have to drive, we have to hop in our cars. So and then in Unit 5, we also talked about urban sprawl and then suburban sprawl, where people left the cities and moved to suburbs. So we like our larger cars, we like our larger homes, and because of that, now we're driving to get everywhere, and that's a real problem when we're talking about non-renewable energy resources that we're using, like the gasoline that's made with the oil, and electricity, because now we have larger homes. We're not living in high-rise buildings anymore. We have these large individual homes, which are very expensive to heat and to provide water to and things like that. So um, let me get rid. I have a lot of videos or I'm sorry, I have a lot of graphs and things in my videos for this unit. So I'm going to be deleting my picture quite a bit, or just hiding my picture quite a bit there. Okay, so it says the average US resident, like I said, uses that 5 times energy as the world average. Developing nations, as we know, are still industrializing and the population is still growing rapidly. And so this will over time increase their per person their per capita use of energy as they get more higher quality standards of living. Their standard of livings increase as maybe their homes get bigger. As people acquire wealth, they tend to move into larger homes. Um, and they tend to get larger vehicles or just larger goods that require electricity or require energy in some form. And so this is why, this occurs. And so looking at this graph here, now we're going to be, just so that we know what we're looking at the energy use per capita, but we're looking at kilograms of oil for that per capita use. So you can see here, Canada uses quite a bit of oil. Here's us in the US, just below them. We have France, Germany, Ireland, UK. That amount of oil nearly cuts in half. They are switching a lot of their energy use over to solar power and other non-renewable forms of energy, wind power, nuclear, other things like that. And then Brazil, China, Bangladesh, and then we had Arethea there at the end. And so that's kind of how we compare to some other countries throughout the world. And then here's just a graph to show population over the year here running along the x-axis. And you can see that more developed countries have always been using a lot of energy. We really haven't changed our trend. But then look at these less developed countries, they're starting to use more and more energy. And as their populations are growing, and so you can kind of see that there. Our populations kind of remained steady and has just grown a little bit since the mid 1900s. Okay. All right. So looking at fossil fuels and the most used energy sources, fossil fuels by far are the energy sources that we're using globally when we're talking about those trends or those patterns on a global scale now. And you can see here, and let me get rid of this picture again. or throughout the world, we really have not made the switch to a non-renewable energy grid. We haven't done that really anywhere in the world very well. We are rising slightly with hydropower, nuclear. Now, I tend to lump nuclear into non-renewable energy sources just because we have so much nuclear fuel that it's going to take a long time to use it up. And we generate so much power with so little fuel. So, but it is a non-renewable. So when I make that mistake and you hear me, talk about renewables and I've got nuclear lumped in there, just realize what's happening with that. All right. And then hydropower. So we like to dam things up. We like to, harness that energy from water, which is really actually a good thing that we did that back in the mid 1900s. But we have oil, coal, and natural gas, which still account for most of our energy usage. And this is from 1965 to 2018. So you can see that these three are increasing pretty significantly, and the consumption has increased so much that, and we're really becoming reliant on these. We should have been focusing more on these non-renewables. We just had so much of this back in the day, and it was cheap to use, and we had all these great technologies. But now we really need to consider making a switch. And so here are what some of those energy resources are being used for. Oil, we know, makes gasoline, which is the main fuel for vehicles. Coal is the main fuel that we're using throughout the world for electricity generation. Natural gas is what we're beginning to use as a secondary resource for electricity, and you can see that consumption has, gone from less than 10,000 to almost 40,000. So it's well, it's definitely quadrupled since 1965. So that's a good thing. We do have quite a bit of natural gas still left, so that's a positive. And then hydroelectric energy is the second largest, but when I say second largest, look where we're at. Okay, so, and then one of the keys with that, with hydroelectric energy, is that we use water to spin a turbine and that generates the electricity. That's what that means. We'll talk about that in a few minutes. And then we have nuclear coming in third. But the second and third race is far behind those fossil fuels. And so we'll talk about these resources more in just a few minutes. Okay, so how does developing a country actually lead to fossil fuel consumption? Well, many residents of less developed countries and nations depend on what we call subsistence fuels. The subsistence fuels are basically it's biomass that has been easily collected or gathered, and it's just around your home. So you can think of, what they would have done, back in the 1800s before we had an electric grid. How did we heat our homes? People went out and chopped down trees. They would go around collecting these little black rocks off the ground, which they realized burn really hot and unfortunately produced a lot of smoke. But that's charcoal. And so it's, kind of like what will eventually become coal if it's buried deep in the ground. But they collected charcoal. Some developing nations use dried animal manure as fuel. And this also drove deforestation, which is what's happening in some of these developed nations. We're cutting down large areas of trees because the populations are growing and they need to come up with ways to cook and produce electricity and other things. So they rely on these different types of fuel sources, the subsistence fuels. And then, like I said before, with economic development comes more wealth. And with wealth, then we tend to want more convenient ways to live, where we're not spending half our day out gathering subsistence fuels. Now we just pay somebody to provide us with electricity. And so this you know, goes right in line with a higher per capita GDP, which is that gross domestic product. If you know anything from social studies about economics, it's the amount of money that a country has per person. And so higher GDP means higher economic development, and then that relates directly to energy use. And so we can see here the energy use per capita versus a country's GDP. So GDP is going to be plotted on the x-axis. This is how much wealth a country has per person versus energy use per capita, okay, on the y-axis. So you can see the kilowatt hours of energy going up there and the dollars going up there, and there's just a direct correlation. If we plotted a best fit line, that would definitely be showing us logistical growth right there. Okay, and as developing nations develop fossil fuels, you know, that consumption is going to increase. I've said this multiple times, so I feel like I'm repeating myself, which I am, but I think that's an important point to make sure that we drive home. Okay, so other some factors that affect the energy source that we actually use in a country. There's three different things. The first is availability. So fossil fuel use depends on the reserves that a country has or has access to. So we use and we get a lot of oil from the Middle East. I think we all know that. There, you know, have even been issues with wars and things happening over, you know, electricity or resources, basically. And so we get a lot of that from the Middle East, and we rely heavily on that availability. Okay. And so you can see here, we are trying to switch to other forms of energy, or we're trying to, you know, get oil from our own country so that we become less reliant on other countries. And so, but we still get tons of oil from the Middle East, and we will continue to. Um, but you can see here natural gas production from US shales. Shales are, we can get fossil fuels from shale. Shale is made of essentially the same, you know, the same type of material as our oil and our coal. And then from oil comes natural gas. And so all those fossil fuels kind of come from those remains of dead plants at the bottom of oceans. And another factor that affects our energy source use is price. So, as fossil fuel prices, and we're generally talking about fossil fuels here because that's our number one energy source that we use. But as those prices fluctuate, um, the you know, cost of a barrel of oil changes on an hourly basis on the stock exchange. So you know, we find new reserves or do we deplete old ones, and then that causes the pricing to shift. And then we have now newer technologies like fracking. We'll talk about that in a few minutes, that opens up even more natural gas reserves, which increases that availability. So that decreases price. You know, more supply means, um, you know, lower price. And so, and then increasing use, people tend to use it more because now it's cheaper than using like coal, or it's cheaper than using oil. And so you can actually watch those prices fluctuate. All right. And then here is a graph comparing the United States to the European Union to Japan. And then we're also looking at the crude oil here. So we're looking at our consumption from the year 1984 in these major areas of the world to 2012. And we're looking at the costs per million BTUs of the resource. So how much did it cost, and how much does it cost now? We can see oil, how it's jumped here, and then our usage, um, or our price. I'm sorry, this isn't consumption, this is price. The price of these things. So you can see in the USA, natural gas prices have decreased significantly because we're actually finding a lot more of it, and developing technologies to get a lot more of it at a cheaper cost. Okay, look at the cost of crude oil versus natural gas, and then look at the cost of the European Union for natural gas prices versus the US. So, that's not a resource that they want to use as much compared to us because we're actually supplying a much larger supply of natural gas. And then another factor that affects energy source use is government regulation. Governments can mandate certain energy source mixes. So, in other words, they can say, we're going to try to be 25% renewable by 2025. It's not the United States. We're not there yet. Um, and then governments cannot, one thing that they cannot do is directly raise or lower prices of energy sources. So it's not the governments that do that, it's the industry that does that, and the supply and demand and available reserves that we saw that does that. Governments can, though, use different things like taxes to increase, tax increases to discourage the use of certain types of energies. They can also provide rebates or tax credits to encourage companies to build, renewable energy sources of energy and try to increase that grid, but they cannot actually directly raise or lower prices. So that's one thing that they can't do, but they can do these other things. Okay. And then let me get rid of this again. You can kind of see these graphs here. It's good to look at graphs. They like to use a lot of graphs, charts, infographics when we're talking about energy sources. It's just something that's easy to put on a graph. Um, and so this is our percent of electricity produced through renewable sources. You can see that Canada is doing much better than we are. We're still fairly light. We're not as light as Northern Africa over here, but we're still fairly light. We should be, I would hope, I would like to see us become, a leader in this field, but we're not necessarily doing that at this point. Canada is doing a much better job of that than we are. And even surprisingly, some of these South American countries, like Brazil, for instance, is using a lot more renewable technologies. Okay, so here's your practice FRQ for 6.2. So from 2015 or 5 to 2018, the annual investment in renewable energy sources in the US increased from 11.4 billion to 46.5 billion. Calculate that percent change. This is a good calculation problem in that investment in the US from those years. And then experts estimate that the US needs to reach 100% renewable energy by 2050, but it's going to require 7.8 trillion. So calculate the percent change this would represent from the investment that we're making right now in 2018 to the investment level of 46.5 billion. Um, or that's what we used in 2018. So what would be the percent change between those two numbers? And your answers, you can always find answers to FRQs on OneNote. I will make sure that I put the Unit 8 answers up, or the Unit 6 answers up for you. And if you have any questions, make sure you're talking to me in class. I'll see you guys next time.